Hello everyone, this is Wilson. So let's compute this limit here. We have x to the x power and then x is approaching 0 from the right side. And for this one, we are going to first plug in the 0 and see what's going on. So the form of this function looks like this, where the base is approaching 0 from the right side, and then the exponent is also approaching 0 from the right side. So that's actually an indeterminate form of 0 raised to 0 power, and, and so that means we cannot draw any conclusion at the beginning, right? And so now let's actually get into computing this limit. So to compute this limit, because we have a x in the base, we also have x in the exponent, we are going to first just let y be this function, so x to the x power, and then we are going to apply the natural log on both sides of the equation. So we are having Ln of y is equal to Ln of x to the x. And then the next step is that we can bring the exponent in the front. So we are going to get x times Ln of x. So just imagine that we are bringing this x in the front. Okay. So now what's the next step? We are going to start taking the limit on both sides of the equation. So we have the limit of Ln of y as x approaching 0 from the right side, right? And then we have the limit of this function that we have here, which is x times Ln of x. And then, yeah, so that's what happens right here. So what we are going to do in the next step is that we are going to consider the right-hand side of this limit here. If we plug the 0 in here, we are going to analyze this form one more time. So this is approaching 0 from the right side. And when we consider that this x is approaching 0 from the right side, we have Ln of 0 from the right side, and that actually is approaching negative infinity. So you can see that this is approaching negative infinity. And so we are actually getting a indeterminate product where we have one factor that's approaching 0 and the other factor is approaching negative infinity. And so since that's an indeterminate form, we cannot draw any conclusion on what this limit is approaching to. And so we are going to first turn it into a quotient. So let's continue. So we have Ln of x to the 0 and then Ln of y, right? We actually don't need to worry about this left hand side right here, so just keep that. And then now the right hand side is that we are going to rewrite it so that it will become a quotient. How do you rewrite a product into a quotient? You can, instead of multiplying the Ln x by x, we can take the Ln x and then we divide by the reciprocal of the x, which becomes 1 over x. So now let's do a quick check again. The numerator, as x approaching 0 from the right side, it's approaching negative infinity. The denominator, it's going to be approaching what? It's going to be approaching positive infinity. So that's an indeterminate form of infinity over infinity or negative infinity over infinity. And so we can apply L'Hopital's rule in the next step. So let's apply L'Hopital's rule in this step here. Then what happens is that we need to differentiate the numerator and the denominator separately. When we take the derivative of Ln of x, we are going to get 1 over x here. And when we take the derivative of the denominator, we are going to get negative 1 over x squared. So that looks like a messy expression, but we can actually simplify it really easily. So if we simplify this, we can write the numerator out first, which is 1 over x. And then we can turn it into multiplication, right? By multiplying the reciprocal of this negative 1 over x squared, which will actually be negative x squared. And then simplifying this expression, we clean that up, we are going to get negative x. And as x approaching 0, then negative x will be approaching 0. So now we actually have obtained the limit of L1 of y. But what we want is actually just the limit of y. So what can we do? We go back to the original problem now. So now we go back to the original problem. The limit is x approaching 0 from the right side, x to the x, is equal to the limit of y, right? Because y is equal to x to the x, so we can replace x to the x by y. And then we can rewrite y as e to the ln of y. And so just remember that this 0 right here, this answer right here, that's actually the limit of L1 of y. And so this L1 of y right here is approaching 0, as you know. And so because of that, then actually our original limit problem will be equal to what? It's equal to e to the 0, right? And so what is e to the 0? It's equal to 1. And so our limit exists and it's equal to 1. And so that's it for this problem. Okay, so if you like this video, please subscribe to my channel and then give me some support. Thank you for watching this video. I will see you next time.